We are going to start this lesson from the point of I ring. I or exit what? Exit pole in a telescope. Okay? Now we shall say that I ring is the best position. Is the best position. The best position for the eye to receive. For the eye to receive all the light entering the telescope. All the light entering the what? The telescope. Entering the telescope. Entering the telescope. And the image viewed is brightest. And the image viewed is brightest. Brightest. Okay? And I shall say that the eye ring is the central image. The eye ring is the central image of the objective formed by the eyepiece. Formed by the eyepiece. Then we say, consider an astronomical refracting telescope in normal adjustment. Normal adjustment. So you have this is objective. This is eyepiece. Then do this. I'm going to have this one here. I'm going to have this one here. I have this one here. The image formed first is this. Then we have this. Then we complete the diagram with arrows. Like that. Then here. We have this. So from there, we shall have something with this letter. This is what we call eye ring. That is eye ring. Now the distance from here, remember this is F naught. This is FE. So that from here to here is FE. From here to here is F naught. So our separation here is F naught plus FE. Then let's say this becomes our VE. The position of the eye ring. So I said that at this position, this is where the eye should be placed in order to receive the maximum light entering this instrument. And at this position, the image which is seen there is very what? Brightest. And also saying that this eye ring is the image of objective which the eyepiece forms, implying that at this time we shall assume objective to be an object, eyepiece to be the lens, eye ring to be the image. Okay? So we shall say that using 1 over f equals 1 over ue plus 1 over ve. So 1 over fe will become, but ue will not become f naught plus f what? Fe. So it become 1 over f naught plus fe plus 1 over v what? Ve. So we are looking for the position of the eye ring. The position of eye what? Eye ring. So that we shall now say 1 over ve will become 1 over fe minus 1 over f naught plus f what? LCM fe into f naught plus fe. Here it is f naught plus fe minus f what? Fe. And this is 1 over ve. So this one will cancel with that. 1 over ve will not become f naught over fe into f naught plus fe. So reciprocate, ve will not become what? What we get as ve? Ve becomes fe over f naught into f naught plus fe. Okay? But we can get from here, we can get the magnification. The magnification of the eye what? Ring. Okay? Can get the what? The magnification. So say, then magnification, that's a linear magnification. Linear magnification equals VE over U. So we shall now have what VE as what? VE is this one. FE over F naught into F naught plus FE divided by F naught plus FE as our UE. So this will cancel with this. Linear magnification will not become FE over F naught. But magnifying power, angular what? Magnification. Capital M is equal to F naught over FE. This implies that capital M is equal to 1 over linear magnification. 1 over linear magnification. Then from there, we can now move on. So what that means, but of course, but linear magnification equals size of image over the size of what? Object. So it will be diameter of eye ring, divided by the size of the object, which is diameter of objective. Therefore, magnifying power is equal to 1 over m, which will not become diameter of objective divided by diameter of eye ring. Okay? So that means magnifying power, we can simply say it is the diameter dO over d what? dE. But also magnifying power is equal to F naught over F what? FE. Then from there, we can go ahead and look at examples. I hope it is clear. Go ahead and look at it. Example number 1. Okay? Example number 1. Examples. We are going to use this worker here. I hope it is clear. Is it clear? So we are going to use this worker here. So what does it say? The objective lens, the objective of astronomical telescope is normal adjustment. So we have the lens here. Normal adjustment. The 5 images focused at what? At infinity. So we have this. The 5 images formed at infinity. So this is the image which is formed. They are telling us it has that the objective of an astronomical telescope in normal adjustment has a diameter of the objective DO is equal to 12 centimeters, and the focal length is 80. So our F0 is equal to 80 centimeters. If the eyepiece has a focal length of, if the eyepiece has a focal length of 80, I think there's a mistake here. The question says that the objective of astronomical telescope in normal adjustment has a diameter of 12 and focal length of 80. If the eyepiece has a focal length of 5, if the eyepiece has a focal length of 5, F4 of E is equal to 5. Correct? If an eyepiece has a focal length of 5, find the magnifying power. So, in normal adjustment, the 5 images at infinity, magnifying power is given by F0 over Fe, which will become 80 divided by 5, giving us 16. That's part 1. Then part 2. Part 2 says position of the eye ring. So we shall say 1 over Fe equals 1 over UE plus 1 over VE. So 1 over VE will become 1 over 5 minus 1 over UE. Minus 1 over UE is F0 plus FE. So 1 over VE, this one here, this is F0, this is F1, the distance is 85. You add them, So it will be 1 over 5 minus 1 over 85. So VE, the position of the objective, will now become, will now become 5, the position of the eye ring, it will now become 5.31. 5.31 centimeter. So you can use the calculator to verify this. Next says, find diameter of eye ring. So magnifying power is equal to diameter of objective over diameter of eye ring. So substitute, magnifying power is 16 is equal to diameter of objective, which is given as 12 over diameter of eye ring. So diameter of eye ring will become 12 over 16. What do we get? 12 divided by 16. What do you get there? 12 divided, I think I shall get like 1 point. You get your answer in centimeters. You don't have that answer. That is the number what? Number 1. Then we go to number 2. Number 2 is this one. You see number 2? Number 2 is this one. I hope you will see it properly. So that's number 2. Okay, what does it say? It says that an astronomical telescope. It says an astronomical telescope has objective, an eyepiece of focal length F4 is 100 centimeters. FE is 5 centimeters. Find annual magnification if it is in normal adjustment. So annual magnification equals F0 over FE, which become 100 over 5, giving us 20. That's one. Then 2. That's part A. Part B. If the telescope is arranged in such a way that the fan image is formed at 25 from the eyepiece, calculate the magnifying power. So magnifying power part B, number 1. Magnifying power is the same as VE over FA minus 1 times D over F0. Remember that? Times D over F0. So what do we get in that case? We shall be able to get negative 25. But remember, VE is equal to negative D. So negative 25. Because it is formed at the near point. At the near point, it is 25 from the eyepiece. So that is a negative because the image is what? Is virtual. So divided by FE, that's 5 minus 1 times D. Okay? So in this case, this is times F over D. F0 over D. Times F0, or F0 is 100. Okay? Times D. In this case, our D, this D was not for the what? For the final image. It was not for the final image. So it will be positive 25. So this becomes 5, negative 6 times this is 4, which is negative 24. Negative 24. Then another question says separation of objective and eyepiece. Separation of objective and eyepiece. So in this case, we don't have. In this case, we are supposed to have. This is the objective. Then this is eye what? This is the eyepiece. So if the image is to be formed at a near point here, this is the image. Then here we should have this one acting as an object for this. So it is formed at F4, then FA is inside. So the distance here is F4, then the distance here will be U what? UE, and this distance is D, which is 25. So we shall say that using 1 over FA equals 1 over UE plus 1 over VE. Okay? So we shall now have 1 over FA, that's 5, minus 1 over VE. VE is negative 25, is equal to 1 over UE. So meaning that 1 over UE will become 1 over 5 plus 1 over 25. And you know LCM is what? 25. This is 5 plus 1. So UE will become this is 25 over 6 centimeters. So that's a separation. So our separation becomes what? Separation will become this plus this. F0 plus C plus UE, which becomes 100. Is it 100 plus UE? That's 25 over 6. Get your answer in centimeters. Okay? Get your answer in centimeters. Then from there, I think I can give you. Okay. From there, I can give you exercise. I'll give you exercise later. I'll leave the exercise here later. Let us go to another refracting telescope. Number 2, the first one was astronomical. But when you are explaining the astronomical telescope, explaining how it works, okay? We shall first say, in normal adjustment, for example, we shall say, if the image is being formed at infinity, you say, point number 1, we say that the objective forms an image of a distant object which coincides with its principal focus. Then you say the eyepiece is pulled in and out until the final image is formed at what? Infinity. Okay? So let us go and look at what? The Galilean what? Telescope. Telescope. Consists of a convex lens, a convex objective lens, and a concave, a concave or diverging eyepiece. Eyepiece of shorter focal length, shorter focal what? Focal length. Then we go in normal adjustment. Stroke, final image at infinity. Final image at what? At infinity. Final image at what? At infinity. So we can draw the diagram. Let's draw it here. So we have this and this. Okay? So we shall say this is objective, this is I1, IP, that's eyepiece, which is the body what? Yes. Now, we're going to have our lens, we'll have this one. We have the other one which is passing through here. So, this one will form the first image at F0. The first image I1, I at F1, F0. Since the final image will be formed at infinity, then it will be at F1, F2, F8. Then we complete. So I have to take there. Okay. Then another is here. Like that. So that this is alpha prime, this is alpha, and this is also alpha. Then this will be alpha prime, then alpha prime will be here, alpha prime. Now here, we are going to add to diverge. Like that. Like that. The pipe image is formed at infinity, like that. At infinity. Okay? So, the distance from here. Okay. So this is h, okay? So we shall say this distance is what? Is FE, and then from here to here, the distance is F1, is F1, F0. So we get the magnifying what? Magnifying power. So we shall say that magnifying power M is equal to alpha prime over alpha. For small angles, in radius, okay? Tan of alpha approximately equal to alpha, which is h over adjacent, and adjacent is F0. Tan of alpha prime is approximately equal to alpha prime, which is opposite, that is h divided by adjacent, which is F what? FE. Therefore, the magnifying power will now become H out of FE times F naught over H. So magnifying power will become F naught over F. Is that okay? So I can remove this now. You go. Not in no adjustment. Not. Find image at T. Find image at near what? At near point. That is not in no what? Adjustment. I have this. This one here. This is objective. Eyepiece. If you can use this one, no problem. Then here I have this. So the start with the other ones. This is the first one is here, which will come and give us some image here. Let me say the image will be formed here. Image 1. Like that. Then this one. Then forming the file image as this. This is file what? File image I2. So we have this. What about others? We have others here. One is here. Another is here. From here to here, connect like this. Then here, we connect here like this. Like that. Then this one is going to be come from here. Another one is this one. It's going to come from here. Like that. And the eye will be here for observing. Then this will be at F naught, not that one, because it is image of the distant party, the distant object. Then this one, this is image is formed here, okay? So it means that it is inside what? F. Okay? So the image formed is what? It is virtual. So then after that, we shall have this is H1, this is H1, H2. The distance from here to here, that distance is G. Okay, so this is alpha prime, which is same as this. Alpha prime. Then the angle subtended by the object is this alpha, which is same as alpha. So that from here up to here, it becomes what? It becomes F what? F naught. Then from here up to here, this will become our U. So we get magnification equals alpha prime of alpha for small angles in radians. So we start from there. For small angles in radians, tan of alpha is equal to H what? H1 over the distance, which is F naught. Tan of alpha prime is equal to H2 over D. So we divide magnifying power equal to alpha prime, that is H2 over D, times F naught over H1. So magnifying power will become H2 over H1 times F naught over D. But H2 over H1 is the linear magnification of the I piece. So this will be VE over F what? FE minus 1 times F naught over F over D. So, but VE same as negative T. Therefore, when we find power, it becomes negative T over FE minus 1 times F naught over D. Like that. Okay? F naught over T over D like that. So, this one is like this. Maybe the other one is the advantage of this one over astronomical. The advantage is that it forms an elective image. The image is formed by Galilean elect or apple, right? That's one advantage. Take note of that. Then the disadvantage tells us it has a small field of view, as you can see. It has a small field of view. That's number one. Number two, it has a virtual eye ring. It has a virtual eye what? Eye ring. So the image formed by eyepiece of objective is virtual. So you may not know exactly that position where you should put your eye in order to receive the maximum light entering the instrument and where the image can be seen, okay, brightest. So you may not know that position. So the disadvantage is that it forms a virtual eye ring and then it has a narrow field of view. Take note of that, please, students. Okay. Then I give you an exercise. This is the exercise now. I know that you'll be able to see it properly. This is the exercise which you find time and then you go through it. Okay? Exercise. When you get time, you just go through that work because the physics is very simple. What kills us is the laziness and not having zeal to go an extra mile. So that's what you have. Then let us go to terrestrial telescope. Terrestrial telescope. Terrestrial telescope. So the disadvantage of astronomical is that the astronomical forms an image which is inverted. Now that disadvantage can be minimized or overcome by using another telescope which will help to solve that problem. That telescope is called what? It's called terrestrial. In that telescope there is a third lens that was inserted in order to make the other inverted image elect. And this lens, we call it electing lens, as I want to see in the diagram. So we can say it is a refracting telescope with an intermediate image. So it is a refracting telescope with an intermediate electing lens of focal length f, which is placed between the eyepiece and the objective. Next point, the electing lens should be a distance 2f after principal focus of the objective lens and a distance 2f before the principal focus of the eyepiece lens. The objective lens forms a real image of a distant object and at its focal point, if not. This acts as a real object for the electing lens, which forms a real elect image at the same size as the inverted image formed by the objective. So let us see how it works. Okay? Let us see how it works. So we are going to have 3 rays. We are going to have 3 lenses. Sorry. The first lens is this. Another lens is this. Another lens is what? Is this. So we have this. This is objective. This is electing lens. This is eyepiece. Principal what? Principal axis like that. We need to move this one here. It's not needed. Then after that, that's principal axis. Then we are going to form, and we are going to have the other rays. The first one is this. The first one is this. Then the next one is this. So let's say that this applies like this. Okay. Yeah. Then you can say, let's have others. This one here. Have this one here. Let's say they are converging here. So they converge from here, like this. And this one, like this. So they converge here. That's the first image of a distant what? A distant object. So this image is going to be made upright. It's going to be made by what? Upright by this one. So let's say that this is the same size, the same image, which is made what? Upright. Then another is this one. And down here. This is. Like that. Now, this one has this way. This passes through FE. Passes through the part FE. Like this. But the image is formed at infinity. So we are going to have this big refracted like this. The image is erect and formed at what? At infinity. Like this. This. Then here, final image at infinity. So the image produced is erect now. Then we shall say that at this point, we shall say that at that point it is F naught. Since the image is formed at infinity, it is also F what? F E. And then the distance to F, the distance from here up here is 2F of this length. Okay? Then also this distance is up to here is 2F of that length. 2F of the what? Of the length. And of course, we shall now say that this is also F what? Okay, even if we leave it like that. So this one also be F what? F1, FE. That will be F1, E. But then since this is F of this one, right? F of this length. Let us call it F of X. F of rectangle length. Then after that, that's what we have now. So advantages of terrestrial telescope is one. It forms an elect image. The image is elect up this side. So it forms an elect image. That's one. Disadvantage. One, it is very bulky as you can see, because the length is increased by 4F from here up to here. From here up to here, it is 4F. So it is bulky. The disadvantage is bulky because its length is increased by 4F. F. That's number 1. Compared to astronomical telescope. Number 2, it reduces, since there is a lot of refraction here, it reduces the intensity of light emerging through the eyepiece. It reduces the intensity of light emerging through the eyepiece. In other words, it reduces the clarity of the image. It reduces the clarity of the image, or it reduces what? It reduces the intensity of light coming out of the eyepiece. So that's what I have. Now, finally, so in this case, I can give you what? Exercise. I think you will see that exercise. Okay? So this exercise, you have to do it. You do this exercise, and please make sure you take to your teachers for marking in case you are at school. If you are at home, you can call us on 0785 132 106. We shall be able to reach you and help you accordingly. Thank you very much.